So this is our review period. We're going to be doing that. So let's just start with any general questions we have. So I have some practice problems with things like NFA to DFA transitions, DFA minimization, and regular expression generation. Those are the three things that I felt like would be the most difficult concepts on the study guide. So I have some practice problems with that, but anything else, let's handle now.
Sorry, this is unrelated, but
yeah,
are we gonna get homework one graded for the test?
It should be graded. Was it not published?
The poster or
It should be on Canvas. Let me look into that real quick, just to be absolutely sure, but the answer should be yes. I believe my grader did say it was done, so I'm going to. Yeah, the grades are in, but they are hidden, so let's make sure we post those. And I will send him a message that says, get good.
oh, pretty dope.
Literally nothing else, just only those two words. And he can figure out what it's about.
I mean, that's the only one he started so once.
I don't actually do that. I'm a way better joker than I am a passive aggressive person, but someone who's doing something. I really respect the effort and time my TAs put into the work that they do.
I realized
Yeah, you would be the one person who's eligible to grade this course.
I was worried you were gonna say that.
I don't think there's any other master's student. The two that have taken this course are graduating.
It isn't five.
So I could probably count like
Unless you can provide me a really convincing argument not to. I will probably advocate for it. That said, the fall enrollments tend to be really low. All right, question. We're wasting time. Questions that I can answer. We have a limited amount of time. Shane, you said you had some questions?
I did, let me go back, because I was trying to see my silent score, but Canvas app refuses to load it.
The suspense is killing me.
Oh, come on now, not even modules is loading.
Yeah, turn off the light.
My Wi-Fi is off, which is funny.
I have a quick question.
Yes.
Questions are gonna be on the exam.
That is a really good question. I do not remember what I wrote earlier this week. I'm doing a last pass on it this afternoon to make absolutely sure I'm happy with everything. But this is not one of the most insane exams that I will give, most likely. So I anticipate everyone being able to finish on time, as long as you know what you are doing. If you are stuck with, what are the rules for this? How do I do this again? And you don't have a good sheet of notes that has the steps to follow in a general problem to solve, then maybe you will struggle and possibly run out of time. But if you know how to apply everything that we have done to a problem, I'm not going to throw something harder than what you have seen in a homework on the exam.
You go over like the amount of points and how the exam is structured again.
Yeah, so in general, it's always graded out of 100, but I very frequently have more than 100 possible points on the exam. I do that on just about every exam that I give. So graded out of 100, instead of offering an extra credit problem or saying that I'm going to curve the exam by some number of points, I just make it out of more points. And that says that you need to know what you are doing to get those extra points. And there's no one challenge problem, it's just there are more than 100 points on the exam.
Can you go over the where it's like read a DFA where A to the N and N is not like the number of A's is not module 3 and not module 5.
Yeah,
Thanks for my homework.
yeah, that was one of the homework problems. So there's no better way to do this. then to find the least common multiple between 3 and 5, so you will end up with 15 states. So now the question is just, are those states mod 3 or mod 5 0 or not? There is no better way to do that, because there is no commonality between, that's the kind of the definition of a least common multiple, is that there's no way to reduce beyond that least common multiple. So we're gonna need at least that many states to be able to figure out and count all the way up to 15, which is that common multiple. We're back to 3 and 5 are both mod 0 is 0, or sorry, mod 3 and 5 is 0 when we get to 15. So that creates the structure of kind of a big loop of 1, 2, 3 is final, 4, 5 is final, 6 is finals, 7, 8, 9 is final, 10 is final, 11 is not, 12 is, 13, 14 are not, 15, or back to 0 is. Happy to draw that out if people want to see that visually. The second part of that, the structure of the exam, I go through each of the different sections of the study guide, and I try to produce at least one question from each of those sections. I try to reasonably keep the number of points relative to the importance of the material. So not necessarily the difficulty of the material, but more from my point of view, what are the important concepts to make sure that you know? What are the important kinds of problems that you should be able to solve? And then a pass to make sure, is this amount of work possible to do in an hour?
So basically what we're about to go over in class is what the big chunky ones are gonna be.
Yeah, so that a lot of it is problem solving, but a lot of it is also just knowing things like, how do you apply this material? Where is this material used? Some justification for, you've learned some tools. When should you be using them? Why is this important? Why are we going over this? Why is it something that you should know and remember or be able to reteach yourself in a relatively short amount of time in 5 years or 10 years? I hate regurgitation style questions, so there will not be anything definitional or particularly memorization focused. Anything of that nature, I would assume to be prior knowledge. I assume that it's on your sheet. I do not assume that you will read the sheet and be able to answer more than a couple of questions that are on the exam. The rest of it is going to be applying that material that is there in a way that allows you to solve the problem. So something like if you wrote down the algorithm for how to convert an NFA to a DFA, then you would see a problem that says, assuming that that's on your note sheet, solve this problem. And that way you don't have to remember or memorize that, because we have to be real. Anyone who's giving you memorization-based questions probably wrote that exam before the internet. At least that's my view of it. When you can Google search or ask ChatGPT for a summary of something, it is useless to memorize something because it takes you a minute to look that up. What I care about is minimizing the amount of time between when you look something up and when you remember how to do it. So in 5 years, I don't expect you to remember all of these processes and all of these steps. But if you built an intuitive understanding of each of these concepts, when you do go back and look it up again, you go, oh yeah, I kind of remember this. I remember the intuition for this. These rules make sense. I know what I'm trying to solve. I know how I'm going about it. So that's what I'm trying to train people to do. And I do take my exams as, I think of them as additional training. It's not an examination point more than it is continue to practice and get experience with utilizing the problem solving tools that we've practiced in class to be able to solve additional problems. So you should feel like after the exam, you did real work and you felt like you accomplished something. It's not just you regurgitated something that you memorized the night before and now you can go flush it from your brain like RAM or bad Chinese. I'm not saying this right at lunchtime. What else can I answer? Yeah.
Just a refresher on the definition of an automaton.
Yeah, so an automaton is a state machine, which means that we're reading from some kind of input, usually a stream of characters or a stream of tokens. We have been able to convert those characters into tokens. There is the states represent kind of your CPU or your processor. You have an optional storage that you can read from and write to as part of this, but it is not part of the input. It is something that is usually blank when you start, and now you can start to store some things in that storage. They represent partially completed solutions, histories, something else of relevance as you're trying to solve the problem. And based on the transitions that you make, based on the input characters that you read, you produce some amount of output or end in a state that says an acceptance or a rejection. You can think of that as output as well. If you end in a final state, output accept. If you end in a non-final state, output reject. So you have storage that you're reading from. You have internal storage that you're working with. You have states that represent where you are in the program. And then you have the output that is the termination of the program that tells you the relevance of the mapping of that input to the output. That can, for everything that we've seen so far, that output is this string in the language that this state machine represents? Which is very important for compilers because we want to figure out something like, is a sequence of characters a legal program in a particular programming language? Yes or no?
So something like a DFA or NFA be considered a stateless or memoryless automaton.
Yeah, it's an automaton without that extra storage on the side that you can interact with. It recognizes all of the languages that do not need that storage. But as we'll see with context-free languages, we do need the ability to store something. And we actually will have the ability to store something. But we have to store things in particular ways. So there's a restriction on how we interact with it. Anything else that I can answer just off the top of people's heads before we dive into some practice problems? I'm not pressuring you to dive into this. So if there are questions, I would like to answer them. And if you think of something while we're doing this, feel free to answer that as well. But maybe I can just get to people started. Yeah,
For the cheat sheet, does it have to be handwritten or can it be typed?
either, don't care.
Oh, we get a cheat sheet?
Yeah, an entire sheet of notes front and back. I don't care what's on it and I will not collect it. That said, you'll get a lot more out of it if you make it yourself. I'm not policing if you give your cheat sheet to someone else, but the most successful people, the most successful exams will come from someone who made that sheet themselves, because the process of transcribing that material will be putting it in your mind. I find that in general, people don't refer to that very much because the fact that they made it meant that they did the studying that was required to know that material in the first place.
Could you go over, for regular expressions, how to correctly apply their precedence?
Yeah, the precedence. So we had, first was star closure. So whenever we see star closure, that is the very first thing that is done. Think of it kind of like an exponent happening before multiplication and addition, because it is also superscripted. That tells you do this before anything that is not superscripted. So the star gets attached to whatever block is before it. If it's a single character, it gets applied to that. If there are parentheses, then it gets applied to that entire thing. So parentheses still do come first.
So does star closure or parentheses come first?
Parentheses, as in, it's not technically part of a regular expression, it's still part of an idea that it overrides the default order of operations. So parentheses, regardless of where they show up in math or in regular expressions, the definition of parentheses is override the default order of operations. So yeah, star closure, then concatenation, then union. If you write something like a positive closure, then that is going to also be the equivalent of a star closure, because it is the equivalent of a concatenation and a star closure. Right, we see why that is. We have something like A or B plus. This is the equivalent of saying we have one copy of A or B followed by an arbitrary 0 or more copies of A or B. You can always rewrite this to be that or this to be that. So you would evaluate the entirety of this as a whole for that. badly with speed eraser. Doesn't do its job anymore. Yeah,
Could you just talk about how to identify, or when you identify if a grammar is regular or not, you just make a DFA for it, or an NFA?
if a grammar is regular, even if a language is regular. If a language is regular, you can do any of. So if you saw an exam question that said, to show that this language is regular, you have 4 paths you can go. Construct a DFA, construct an NFA, construct a regular grammar, or construct a regular expression. Any of those will answer that problem. Although if the problem specifies make a DFA or an NFA, then you will need to apply the appropriate path. Make sure that you use that technique to show that it's regular.
You said DFA, NFA, regular expression, and what was the last?
Regular grammar.
What algorithms would you suggest, like having their note sheets?
I would put the NFA to DFA algorithm on there. I would put the DFA minimization algorithm on there with the table. So NFA to DFA conversion, DFA minimization. Those are really the only 2 major ones we've covered, I think. Maybe something about construction of regular grammars. How does one go about that process to parse it if you have something like a right linear grammar? How do you parse an actual string into that?
Could you give us a quick example of the table for reducing?
Yeah, I actually have a few of them here on the practice problems that we can go into.
Yeah, I was about to ask that. Can we go over like the DFA minimization? I remember the table, but I forgot how to use it.
So here is one of the pictures from our homework. Our practice problems here are going to be B and E. So we want minimal DFAs for each of these languages. What's fun is for B, when we see that union, we really want to make an NFA for it because it says we want to be able to go in one route or the other route. But because each of those pieces of the union start with a different character, an A and a B, it's pretty equivalent to make a DFA for it. So A to the NB, n is greater than or equal to 1, union B to the NA, n is greater than or equal to 1. So let's come up with a DFA, and then we can show or prove that it is minimal. So thoughts on how do we start constructing this DFA? What do we want to do? Yeah.
You have your Q0, the initial state, and then from there, you either read in A or read in B. And whatever state that it reads into for both of them, moves back to itself on that A or B character.
Yeah, so we're gonna make a Q1 with a self loop on an A and a Q2 with a self loop on a B. Anything that should be final?
Wait, we're working on
Not,
Work on that.
no, because we have to see if there's one B or A depending upon the route you chose. When you see,
Yeah,
We need A1 and A2 to both go to another node respectively, like two. Sorry, we need A1 to go to another state.
yeah, we need to be able to see the final. Something's happening up there.
And then
B and an A,
have that loop in that new state.
yeah,
And then the same thing with A2 as well.
so we need a Q3 that is final on a B, that is the B that we see at the end of A to the end. And then we would need a Q4 on an A. Do we want to loop on Q3 or Q4 on anything?
We want it in a trap state.
Yeah, we need to go to a trap state for sure. So when we see this last B, nothing is allowed after this B. This is the one and only B that's going to be in this portion of this language. And this is the one and only A that's going to be in this portion of this language. So from Q0, we're picking a direction to go. We're either going through the A's followed by a B that terminates where we accept, or B's followed by an A that we terminate and accept. That'll be interesting to see if we can do that. So this is our trap that we loop on A and a B, and we want to, if we see anything from here, directly go to that trap state. So we have one idea that maybe this is not minimal. Maybe we can combine Q3 and Q4 somehow. Intuitively, does anyone agree that somehow we could collapse these two states? Think so? Anyone think they're distinct enough that we cannot? Interesting. I think there's going to be a lot that we will learn from this table. So I'm going to draw this table as we have Q0, Q1, Q2, Q3, Q4, and Q trap. I'm not even going to bother drawing Q0 on the columns because there's no reason for us to consider it. So we're going to have Q1, Q2, Q3, Q4, and Q trap. And now we have the zeros all here, the ones we don't care about, the twos to here, the threes to here, the fours to here, and this doesn't really need the trap. Everything for the trap is going to be in the column. Excellent. So let's start this process. How do we start the process? Finality. So we're going to look at pairs of states, and we're going to put X's wherever there are different finalities between pairs of states. So for Q0, it has different finality from Q3 and Q4. For Q1, differences at Q3 and Q4. Two differences at Q3 and Q4. Q3 will have a difference at Q trap, and Q4 will have a difference at Q trap. I'm not looking at something like 3 is different from 1 because we already determined that 1 is different from 3. There's no reason to flip them. They're not different. If they were, then we wouldn't have drawn these squiggles. So now what we have are some question marks at every other point in this table. So here is our initial table of what we know with 0 steps and what we don't know with 0 steps. Questions on this setup?
So you're just taking all the states that are different. So state 1 is different from state 4 and 3, 2 is different from 3 and 4, and 0 is different from 3 and 4.
Yeah, because they already have different finalities. If we have somehow reached Q0 and Q3, we can show with no further symbols being done that this is distinct from each other because one accepts and one rejects. So they have to be distinct.
While your horizontally rows don't start with Q0, so. Like
Here in the column?
Yeah. for your column.
Because Q0 is already mapped to every other thing. The reason the trap is here is it's mapped to every other thing on the columns. So
What
we,
happens if Q0 ends also with Q0? Like, man, that's the end state.
do you always have indistinguishability between a state and itself? It's like saying, what is the difference between Jimmy and Jimmy? It can't be, there are no differences by self-reference. So we don't need to prove the distinguishability or indistinguishability of a state from itself, because they're always indistinguishable.
Give this in a question mark for Q3 and Q4.
Yes, I am. Thank you.
That was going crazy.
Usually it's not you, it's me. Yeah, we don't know between Q3 and Q4. It's especially important because they're the two final states. Yeah.
I missed it. What did I? The final state.
The what, sorry? The X's represent, we know they're distinguishable. And they're distinguishable initially because they have different finalities. So a state that is non-final is distinguishable from a state that is final, because if you can end up in those places from that point on, you can say that regardless of where we move, with no further string, the result of this is different. An indistinguishable state says that for every possible string that we could get from here on out, including the empty string, we will end up in states that are exactly the same finality. So because of that, they are indistinguishable. For no possible further substring in the language could we possibly end up in where one state accepts and one state rejects based on those two states. So that's the definition of indistinguishable and means that they can be combined. So the X's represent distinguishable. We will not combine those states. The question marks are we have not proven distinguishable or indistinguishable. We need further work to show that. All right, so we will start by looking at Q0 and Q1. Since they are the same finality, they have to be because there's a question mark. What happens when we transition on an A? Both go to Q1. Obviously, a state is not distinguishable is indistinguishable from itself, so that doesn't prove distinguishability. How about Q0 and Q1 on a B? We go to the table, we look at Q2, Q3, and we see an X. So we can backtrack to Q0, Q1 and say on a B, they're distinguishable. Because they map to states on just that B that have already been shown to be distinguishable. Q0 and Q2. What happens on an A?
One is in Q1, Q0 is in Q1, and Q2 is in Q4.
Q1 and Q4, according to our table, is distinguishable. We're going to backtrack to Q0, Q2. Those are also distinguishable. How about Q0 and Q trap? That is a question mark. What happens on an A? Q1 and Q trap stays in Q trap. So we look at Q1 and Q trap. We see a question mark, so we can't backtrack any information. We don't know. How about Q0 and Q trap on a B? Same thing. They go to a Q2, Q trap, question mark, can't state anything yet. So we're going to leave this as a question mark for now, and we'll move on to the next one. Q1, Q2. On an A, where do we end up? Q1 and Q4. We look at our table, we see an X. We can backtrack to Q1, Q2. They're distinguishable. Q1, Q trap. On an A. Q1 and Q trap. Question mark. Can't say anything. Q1 and Q trap on a B. Different. We end up with Q3 and Q trap, which if we look is an X. We will backtrack that and get to the Q1 Q trap. Those are distinguishable. Next question mark, Q2 and Q trap. Now we can start to, I think, have an intuitive, what character allows us to distinguish Q2 and Q trap? A. On an A, we end up in Q4 and Q trap, which is that X. We're going to backtrack, put an X. Q3 and Q4. Yeah, we can't state anything about that, can we? So we're going to leave it as a question mark. And draw my arrows. We made at least one change. We've asked questions about every single question mark now in the table. So since we made at least one change, we're going to loop back around and ask questions about the question marks again. So Q0 and Q trap. On an A, where do we end up? Q1 and Q trap. We look at the table. We can't look at finality anymore. Because when we looked at this before, we were able to, on something, show that that ended up in different finalities. We backtracked it. So it still looks like they go to the same finality, but Q0 and Q trap end in Q1 Q trap on an A, which has an X. So we're going to backtrack that X, and we now have proven distinguishability of Q0 Q trap in 2 steps. Because this is iteration number 2, we can show that on an A and then a B, we end up A, B, and now we have different finality. So on the second iteration, we're looking through for 2 steps in order to get to different finality, but we're doing it via 1 step and back propagating that distinguishability 1 step earlier. All right, last one, Q3 and Q4. On an A and a B, they still both end in Q trap. Since we made at least 1 change, we're going to loop back around, look at every question mark. Q3 and Q4 still end in Q trap. So this process is terminated, and now we can replace every single question mark that remains with a check mark. That check mark says that these 2 states are indistinguishable, and we need to combine them in order to get a minimal DFA. So what could we do to minimize this? What do we do from here?
Line 2 and 2.
Yeah, how do we do that?
Like a multi-edge from, or you'll have an edge from Q1 to whatever you want to name the.
Yeah, so are we getting rid of Q3 or Q4? Doesn't matter, but let's pick one.
Q4.
Q4, that is a higher number. Higher numbers are bad. So if we get rid of Q4, anything out of Q4 doesn't matter. We don't need to consider it, but we need to redirect edges that are coming into Q4 into the edge that is the equivalent state. So this A, instead of going to the old Q4, is now going to go to Q3. Any intuition for why this DFA is equivalent to the original one? Why did that work? Why does this represent the same language?
Because both Q3 and Q4 on any input read would go to the same state.
Yeah.
And they didn't have any states that they could go after that.
Yeah, the key insight for this one is if you find yourself in Q3 or Q4, you read anything, you go to a trap state, no matter what. So it doesn't really matter which one of them you are in. You have 2 different places. Think of it like, I don't know, jail cells, 2 different jail cells, where if you say a single word, you are put in solitary confinement. Why not just combine the 2 jail cells? Why pay 2 different guards to guard 2 different jail cells if someone's going to say something, put them in solitary confinement? You can slash that budget in half, pay 1 guard, merge the 2 cells, and now if anyone says anything in that 1 cell, send them off to solitary confinement. Followed by Admiral Akbar. Any questions on that? I don't think we want to try to draw the table for E, but I leave that to you as an exercise. If this is something that you feel is a weakness or something that you would like to get additional practice with. Again, this set is up on Canvas. You're welcome to take a look at these problems and solve them. Yeah.
If we can get there through a separate or a different method, do we have to use the table still?
You do not have to use the table as long as your method is correct. If you were using something like the equivalence classes that I was talking about early, you can only split something out once every element in a row or column is an X. So you're not just looking at pairs of things. Once you find a pair that is distinguishable, you can break one of them out. You have to be able to show it's distinguishable from everything else in order to break it out into its own equivalence class.
I have a question about that.
Yeah.
So if you had a row like that, and you had one thing that was indistinguishable, so you had one of the one was a check. Well, I'm thinking about like the top where you have like 5 elements that are 5 states, and if you had one of them that was a check mark, could you break the rest of them out and I guess I'm a little confused.
Well, it would be about whether there's one or two check marks in your table. If there are any question marks left in that, then you don't know if it's distinguishable from that. So if they were in, let's say we have a big equivalence class here of all of the non-final states, Q0, Q1, Q2, and Q trap. Let's say I proved that Q1 is distinguishable from Q0 is distinguishable from Q1. And then I tried to say, based on that, all right, well, I can pull one of these out. All we're saying is that there is an X here. We haven't shown anything about the rest of this in that same equivalence class. We have to show that it's distinguishable from this and that to be able to pull out Q0. We have to show that Q1 is distinguishable from Q0 and Q2 and Q trap to pull that one out. So it's basically the same work as the table, except that I think you will make more mistakes if you do this than if you have a visual way of representing it, which is why I changed my mind after showing the equivalence classes the first time and thought, you know what, there's a way more visual way of doing this. I'm just going to transition to doing this the visual way because I think it will end in people making fewer mistakes.
Could you go over just like a practice problem of like creating regular grammars?
Yes. I will actually use the result of, let's see, blah, blah, blah. Then the next one. All right, let's find a regular expression of these, and then we will take the regular expression that we generate and turn that into a regular grammar. I think that'll violence. Kill two birds with one stone. If we really want a challenging one, we can do C.
Actually, I think for our first iteration we ever did for the DFA, did we include B and A on Q3 or Q4? Did you just do just B and just A on Q3 and Q4? Because that would have instantly gave it away if we had done that correctly. Because it's a DFA, so we have to consume any possible character in this state.
Right, and if you're going to the same state, you can, you're making the conclusion that if on any character you go to the same state, one of those is combined.
Wait, are we going over 19?
So yeah, any of these would be accessible. So I will let people vote which one we want to do. Anyone stick out at, these are 5 different problems. 8? Yeah, let's do that. A to the n, b to the m, such that n plus m is odd. I like that one.
You have a solution for these on the slides too.
I have them in the notes of the presentation, and the presentation is up on Canvas. So yes, you will have the solutions for these to check your work. I wanted to make sure that those were there. I'm going to upload them as practice problems. You need to be able to check your work. Any insights for how to start with the problem? How do you break it down into cases? Or how to start to consider it? Yeah.
Well, you either make it odd, you can also, you can have one be odd, so you have one character between A or B,
Mhm.
your first character, and then after that, you have to add one characters. It's
Yeah.
those even numbers afterwards.
Okay, yeah, that's a great start.
Then I just same idea, we're sort of splitting into two cases. N has to be divisible by two, and N cannot be divisible by two, or vice versa, or.
Yeah. Yeah, so for N and M, we either have even odd, odd even, or odd odd. Even and odd end up with an even number of N plus M. So we don't want to consider them at all, they're not in the language. The only two that we want to consider is N is even, M is odd, or N is odd, M is even. That's the only way that N plus M ends up odd. So we want to be able to have an arbitrary number of A's, except that they need to appear in pairs. So you can start with something like AA star, and you want to end with pairs of B's. What goes in the middle to ensure that it's odd?
Single pair.
A single A or B. If it's an A, it pairs here and makes it odd even. If it's a B, it pairs here and makes this even odd, which are the two cases that we need to be able to show.
Which one are we doing again?
This is 8.
Oh, 8, sorry, I thought
Yeah.
we were doing the top.
The answer that I got was, I had A and then double parentheses. A or B. And parenthesis, open parenthesis, A or B, double close, star. And then I did the same thing for, or B.
Oh,
sorry,
here, with a B there is the, or
And then
B.
just do the whole,
Because all the A's have to come first, I think is where we're gonna struggle here, is that this star here on this allows us to pick AB or BA, and then repeat that some number of times. So I think that's the concern I have here. And then if you're starting with a B, we can't see A's at all. A great idea, and I appreciate your sharing it so that we can discuss what is good. All right. Questions on the solution or other thoughts?
I was wondering how you would approach C.
This 19C?
Yeah.
Yeah, that one's gonna be fun. Let's talk about that after we do the grammar, the linear grammar for this, because I do want to give people a hint for how to go, but I'm also looking at the time and we have just a few minutes left. I will have office hours after this as well, if people have time to swing by, and we can go over any of these.
C seems like there's a good starting age, because you have to have A, B, and C within this language's alphabet.
Which
in
comes
any
first?
possible order. Doesn't matter the order, because you could have A or B or C before each one.
But then how do you know which one was selected? Because then you need to see the other two. So let's do the grammar for this. So we know that we need to start with a start non-terminal. If we're parsing this left to right, that means the non-terminals are going to appear on the right. We're making a right linear grammar. Remember, the difference between left linear and right linear is where the non-terminal is. So a right linear grammar will have the non-terminal on the far right. We can have any number of terminals followed by a single non-terminal. We also want to parse this from left to right. So let's break this down into chunks. Chunk 1, chunk 2, chunk 3. I think help us to be able to see what the non-terminals are to get the structure of this language. So let's look at the first chunk of this language. We have AA star. How do we produce this as an S? Or
AA was the non-term.
what non-terminal do we want? How many times are we allowed to do this AA? Any number of times. So we're going to recurse on the same non-terminal. Since this is optional, at any point that we do this, we should have the ability to just move on. So let's say we can move directly on to the next non-terminal. saying we're done producing these A's. So the goal of this A is to produce the single A or B that is necessary. How do we do that?
A or B.
If we do that, we now have terminated the string, saying that this is the end.
Oh, wait, we need to have like another one where it's B so that I can.
Yes, both of you are absolutely right there. We need to now, after we see that, I'll move this a little bit further. We see that and transition to the next point in the string. So now we've moved past this. We've consumed that single character and we cannot recurse that. So we cannot see multiple A's or B's. If there was a star here, then we want to recurse to the same non-terminal. But because it's a single one, and we want to move on to the next one. So what does B look like?
B and then lower two lower keys.
So we need to make sure that these are, all the non-terminals are happening in the same farmost right position. So it might be, you might think that you could do something like capital B, 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 but now you wouldn't have a linear grammar. You would have some productions that are left linear and some productions that are right linear. So you want to make sure you have consistency across your entire grammar. So we need to make the BB lowercase followed by the capital B. This allows us to recurse this an arbitrary number of times, just like we would expect to see it in the regular expression. How do we terminate? How do we say we're done?
Or lambda.
Or lambda. Yep. So this is kind of the algorithm that I would follow, is I would break down an expression like this into its components. And then I would try to map each of those components to some kind of either recursion or termination. Whenever you have that termination of that component, if there's another component afterwards, go to the next non-terminal. If it's the very last one, terminate with lambda. So this produces a linear grammar. We are unfortunately out of time. So I think the hint for getting started with C is think in terms of combinatorics.
What?
Combinations of the order in which those symbols could occur. Because if we need at least one occurrence of each symbol, we don't know which one comes first. And that is going to be what creates the headache that you need to get around to be able to solve this kind of problem. We need to know which symbol comes first, which either means we need to have some way of identifying it, or we need to iterate all of the possibilities.
Yes. Is there an elegant solution to C?
It's not an elegant solution to
That's
C.
what I was thinking, because I was looking at it and I started doing it and I was thinking there's no way there's an
I don't even have the
elegant
full solution on the notes part of
Okay.
this. I just get it started.
Okay,
I
because I
would not throw this on an exam.
Yeah,
It
I-
would take you a chunk of that hour just to write the solution.
I was writing it down and I thought, there's no way to do this good.
Yeah. But I wanted to throw something like that on there, just so that you can start to get that intuition of when is there an easy solution, when is there not. Yeah. Yeah.
Yeah.